Gabrielle. I'm doing homework 2 part C. And so what it's asking is we are going to be using the von Neumann stability to figure out why R in this Crank-Nicolson is not constrained by a particular R value like it was originally, which was that I couldn't go past 0.5. So if we look at this real quick, I'm going to copy what we did on part B. This here we're going to use. Copy. Okay. Okay. So, with this, we want to do the von Neumann stability. And that is pretty much saying to us, we want Tj n plus 1 on this side and Tj n on this side. And also with the von Neumann stability, we knew that Tj plus 1 is equal to e to the ik delta x. So, and so forth. And then the negative version, so the j minus 1, is just negative in the exponential of that, right? So what we're going to do is let's first push n plus 1 stuff on one side and the n's on the other side, which we already have, but we're going to do the Neumann stability of that. So first we have Tj n plus 1 is equal to negative r of e. So this is minus 1, so this is going to have a negative I k delta x, and then plus 1 plus r, and then minus r I k delta x. And then I'm going to have is equals, and I'm going to put the bottom down below. So then we have Jn, and then multiplied by that is going to be r, and then we have e to the negative ik delta x plus 1 minus 2r plus r e I k delta x. And then the next thing that we know that we've already seen before is that e to the I x is equal to cosine of x plus I sine of x. Right, so we can substitute that in for what we know about this. So it's going to be ik delta x is equal to cosine of k delta x plus sine of k delta x. And then if we do the negative of this as well, so e to the ik delta x is equal to cosine of k delta x minus I sine k delta x. So these cancel out, and so we get that. And then they both have those r terms as well, so we can combine those into the two. So let's combine them, and we have Tj n plus 1 is equal to negative 2r cosine k tx plus 1 plus 2r, and then is equal to 2 Tj n, and then we have the 2 r cosine k delta x plus I minus r is equal to each other. Now if we divide by this one, and we come down here and we divide by it, and then we pull out the 1 minus 2r. So let's do that. So it's tj n plus 1, tjn plus 1 is equal to tj, and then we're going to pull out. So it's going to be negative 1 t. I'm going to move it down a little bit. Let's get some more room. Okay, so r is minus 1 minus 2 r2 2 cosine of x. And then this one is 1 plus 2r, 1 minus 2 cosine x. Actually, I don't think this is a 2 either. I think this is just this. So this is cosine. There's no 2 in front of it. So from this, we know that tjn plus 1 is equal to tjn. Then we have this here. So what about cosine? Cosine is going to give us something from negative 1 to cosine 1, right? So if we plug in negative 1 into this, because 1 is going to give us 0, and this will work out if it's 0, just give us 1. So if we do negative 1 in this, it'll be negative 2. So this will change to this. 1 minus 4r over, well, okay, I'm just going to do this. So we have 1 over negative 4r plus 1 over 4r. So let's say our value is 3. So if we're plugging in 3 for r, that will be 11, because that gives us 12. This will give us a 13. Negative. So this is telling us that pretty much is this number will always be smaller than this number here, than the denominator. And that's going to help us because we're not going to go into infinity. It will always be a fraction like this. It will always be approaching 1. No matter how big r is going to get, it will always be approaching 1 instead of reaching to 1. So that is always good. That means the time step between jn plus 1 is always going to be, is never going to be bigger than tjn. So that is always helpful. So whatever the number of r is going to be, it will always be less than, the top will always be less than the denominator. So the numerator will never be bigger than that. So it will never be approaching affinity. It will always be approaching 1, which is what we want, because if it's approaching 1 and never is 1, then tjn, so tjn plus 1 will never be greater than tjn. And that's what we want. So this is showing that pretty much that this will always have stability with it, and that r can be any value. So that is the end of homework 2.